Hi, good morning students. So in the previous class we learned about the electric motor. So electric motor means the principle involved in electric motor means it is the conversion of electrical energy into electrical energy into mechanical motion. Or simply we can consider it is the principle involved in electric motor is it converts electrical energy into mechanical energy. Now in this class we are going to learn about electric generator. So electric motor one or electric generator. Okay. Electric generator. So what is meant by electric generator and what is the use of electric generator and what is the principle involved in electric generator? We'll learn in this concept. So here the first one, the main principle involved in an electric generator is it converts mechanical energy into electrical energy. It converts mechanical energy into electrical energy. In the principle involved in electric motor is it converts electrical energy into mechanical energy, but in electric generator it converts mechanical energy into electrical energy. So just note on that point, the principle involved in electric generator. Principle involved in electric generator is it converts mechanical energy, it converts mechanical energy into electrical energy. It converts mechanical energy into electrical energy. So this is the principle involved in electric generator. Okay. So by using mechanical rotation or by using mechanical motion, how to produce the electrical energy we'll learn in this chapter. For example, if in old cycles, so it contains the dynamo. So the word dynamo. So by pedaling the cycles, so pedaling means so it helps in the mechanical motion. So by applying the pedals, the wheel starts rotating, and by using that method, the mechanical energy is converted into electrical energy. So the device used in that is dynamo. Here, okay, here they give on figure. Based on the phenomenon of electromagnetic induction, the experiment studied about generate induced current, which is very small. Okay, so in by using electromagnetic induction method, because by with the magnetic effect electricity is produced, and by using the electric effect magnetic field is produced. So we learned everything in that. So in all that case, the produced electricity is very less. Now to produce some large amount of energy, so we are using this electric generator. Okay, electric generator. For example, if you consider joke, so in that joke falls, the water falls from higher place. Okay, this is mountain. For example, the water falls from higher place, and here they have wheels-like structure that is known as turbines. Okay. Turbines. So when water falls on that, so the turbine, the wheels, when the water falls on the arms of the wheel, so then arm starts rotating, and this is connected to certain generator which produce the due to mechanical. So here water falls, so because water present at that's why it contains potential energy. Potential energy. So potential energy means the energy obtained by the object due to its position or deformation in its structure. So here the water present at higher position, that's why it contains potential energy. Now the water is moving. So while moving from higher position to lower position, it attains the kinetic energy. Because we know that kinetic energy means energy possessed by an object with its motion. So here it contains kinetic energy. And then the water from higher position, it falls on the turbine, or it falls on the arms of the turbine, and the turbine starts rotating. That means rotational energy. So rotational energy comes under mechanical energy. Mechanical energy. So then by using the turbines and by using some generators, we are producing electrical energy. Okay, therefore the final product is electrical energy. So that's why, therefore from potential energy we converted electrical energy. So if potential energy it converted into kinetic energy, then that is converted into mechanical energy, then it is converted into electrical energy. So that's why we have one law, so that is conservation of energy. So energy can neither be created nor be destroyed, but it can change from one form to another form. So energy can neither be created nor be destroyed, but it can change from one form to another. So here, the energy initially is in that potential energy form. Then it is converted into kinetic. Then it is mechanical. Then it is electrical. But here we are using for electric generator. The principle involved is it converts mechanical energy into electrical energy. It converts mechanical energy into electrical energy. Just comment me what is the principle involved in electric motor. Just comment me the answer. What is the comment me what is the principle involved in electric motor? What is the principle involved in electric motor? Comment me the answer first. So the electrical generator, the principle involved is it converts mechanical energy into electrical energy. So now I am asking about electric motor. What is the principle involved in electric motor? It converts electrical into mechanical energy. Okay, then the next one. They given diagram, the illustration of the principle of electric generator. Or the diagrammatic representation of electric generator. Again, the previous electric motor, armature is present. It is a rectangular shape. On that many number of coils are mounted. And here also same armature is considered, and armature is kept again between the same two permanent magnet, two poles of the permanent magnet. One is north pole and another side is having south pole. Then two powerful magnets, one is north pole, another one is south pole. This is armature, and the namings are A, B, C, D. Then an axle is present, so it is for support. Then one ring. So in electric motor we use split rings. Split rings. Okay, here we are using rings. Two rings. Okay, full complete ring. Then another ring on the lower part. So the name for the rings are R1 and R2, and brushes are attached to the ring. For R1 the connected brush is B1, for R2 connected brush is B2, and the armature is connected to the brushes B1 and B2. and then next one is B1 is connected to a galvanometer as well as B2 is connected to a galvanometer. B1 and B2 are connected to a galvanometer. Okay, this is a simple representation of or the diagrammatic representation of electric generator. Just look at the figure from your textbook, otherwise with the help of board. Electric generator. So the principle involved in electric generator is it converts mechanical energy into electrical energy, and here totally we consider different parts. So one is armature, one rectangular shape, on that plenty number of coils are wounded, and two poles of permanent magnet north and south, and support, and two complete rings are used. They are named as R1 and R2, and for each ring brushes are connected. Brushes are named as P1 and P2. So this is the brush P1 and the second brush P2, and P1 brush P1 and P2 are connected to a galvanometer, and the rings R1 and R2 inside are insulated. And for here I told you that mechanical energy is converted into electrical energy for the so here in the previous in the motor here battery was present, so that is to supply energy, but here galvanometer is present, so the working of galvanometer is it converts, so it is used to measure the amount of current as well as direction of the current. Okay, in use of ammeters it measures only magnitude of current, but in galvanometer it is used to measure magnitude of current as well as the direction of the current. So these are the arrangements. Just try to draw fast. The next one. Here, so this is R1 and second ring is R2, first brush is P1 and second brush is P2, and the principle involved is it converts mechanical energy into electrical energy. So for the mechanical motion of the armature we have to connect one handle. Okay, so this handle is used to rotate the armature. So just I am comparing electric motor and electric generator in between. See here. So in electric motor, with the help of battery, the electricity is passed and the armature starts rotating. But here there is no connection of battery. Here we have to rotate the armature mechanically. Okay, this is the arrangement and the principle involved. Now I will explain you the working. Okay, listen carefully. So initially, with the help of the handle, the armature is start rotating. So initially, RAB moves upward and RCD moves down. RAB moves upward. RAB moves upward and RCD moves downward. Okay, initially what happens when the armature is rotated with the help of handle, the arm AB moves upward and arm CD moves downward. That means it is clockwise rotation. Okay, clockwise rotation. And in that case, so it is the arm AB moves upward, arm CD moves downward. So this part is considered as internal, and this part is considered as external circuit. Okay, so this is internal circuit, this is external circuit. The armature is considered as internal circuit, and the brushes and rings are considered as external circuit. And your galvanometer is used to find out whether with the help of the mechanical motion electricity is generated or not. The use of galvanometer is, it is used to find out whether the electricity is generated with the help of mechanical rotation or not, and if generated, how much amount of electricity is generated from that mechanical motion. Okay, that is the use of this galvanometer. So therefore, in internal circuit, in internal circuit, current flows from ABCD direction. Current flows from ABCD direction. So that is in internal circuit. Now, when we come to external circuit, see here ABCD. Then in external circuit, it moves from B2 to B1. So this is B2, brush B2, then it is comes to B1. Okay. In external circuit, current flows from B2 to B2 to B1. So when the armature is rotated with the help of handle, the arm AB moves upward, arm CD moves downward, and in the internal circuit the electricity is produced, and that is moving in the direction of ABCD, and in the external circuit the electricity flows from B2 to B1. So that is detected with the help of galvanometer. How many of you understood this? Just comment your name. First, this is the first part. And click on the like button. This is the first part of electric generator. Okay, then in the next case, the again armature is in the continuous motion, and now initially AB moves upward, CD moves downward. In the second case, CD moves upward, AB moves downward. Okay, then it is rotating, because initially the armature ABCD is arranged perpendicular to these two permanent magnets. So now initially it is moving in clockwise direction. Now it is moving in reverse direction. So therefore, in the second case, CD moves upward and AB moves in downward direction. AB moves downward. Then again, electricity is generated and that is detected with the help of galvanometer, and now we have to see in which direction the electricity is moving in internal circuit and external circuit. In internal circuit, the current flows from DCBA direction. DCBA direction. The current flows from DCBA direction, and in external circuit, in external circuit, current flows from B1 to B2. So in the first case, the current flows in the internal circuit in the ABCD direction, and in the external circuit, the current flows from B2 to B1. Now in the second half, in the anti-clockwise direction, the current flows from DCB direction in the internal circuit, and in the external circuit, the current flows from B1 to B2. So therefore, electricity is generated, but it changes the direction or it changes the polarity. So one time it is moving from B2 to B1, another time it is moving from B1 to B2. So that's why with the help of mechanical energy, electrical energy is generated, and that is known as alternating current. So alternating changes the direction, and the graphical representation of alternating current is like this. Graphical representation. So this is the distance traveled and this is time taken. If you consider, then the graph is like this. Okay, for DC, the graph is like this. And one of the most important in our daily regular in homes and everywhere, we are using alternating current instead of direct. Okay, direct current, that is DC, we are using in batteries or cells, and alternating current we are using for home appliances and in factories, etc., etc. So that is the main reason involved in this is the alternating current is transmitted from one place to another place without much energy, without much loss of energy. So that is the main reason. So in our country, we are producing the electricity in different places, but we are getting that energy with the help of transmission lines. And here in the between, the moderator and amplifiers are present, and the current will reach us with minimum loss. In our country, the frequency used is 50 Hertz. Okay, the SI unit of frequency, SI unit of frequency is Hertz, HERTZ, or capital H, small z. So it is the name of scientist again, and the frequency here is 50 Hertz. And here 50 Hertz means 100 waves per second. Okay, and the potential difference in the circuit, potential difference is 220 volt. Frequency is 50 Hertz and potential difference is 220 volt. This is frequency in India. Okay, just note down these two values. The frequency is 250 Hertz and potential difference is 220 volt. The principle involved in electric motor is it converts electrical energy into mechanical energy, and the principle involved in electric generator is it converts mechanical energy into electrical energy. So next one is very important concept, that is domestic electric circuit. The figure is given in page number 132. So domestic, the schematic diagram of one of the common domestic circuit. Just go to that diagram and I will explain about which are the lines present in the electric circuit. Totally we have three kinds. One is live wire and neutral wire. So they are the very important. And so here in our homes we receive supply of electrical power through main supply, also called mains, either supported through overhead electric poles or by underground cables. One of the wire in the supply, usually with red insulation cover, is called live wire. So first one is live wire. So the color of live wire is red. And next, another wire with black insulation, that is called as neutral wire. Neutral wire. It is insulated with the help of color black. Wire with black color is called neutral wire. In our country, the potential difference between the two is 220 volt. Okay. One of the wire in the supply, usually with red color, red insulation color, is called live wire or positive. Another wire with black insulation is called neutral wire or negative. Another is ground, that is represented with the help of ground wire, that is having the color green. And the next one that is very important, that is what is the use of fuse? What is the use of fuse? So in our homes we have sometimes we will tell fuse is gone. So that means it is a wire which is having low melting point. Low melting point. In electricity chapter also we learned about the uses of fuse. Just comment me what is the use of fuse in electric circuit. Comment me what is the use of fuse in electric circuit. So that is a very important question. Use of fuse. Okay, in electric circuit, why we are using fuse and what is the reason behind that fuse? So fuse is used to safeguard the electrical components by high electricity or by hazardous electricity. Okay, if for example for a instrument, if 20 ampere or 20, for example 20 ampere, I will consider this for example 20 ampere of current is required, but if comes 40 ampere of current, then the device will gets damaged. Okay, or the device will start burning because of high energy. So to safeguard the device, the fuses are used with low melting point. So it has a particular melting point capacity. So if a current greater than that value comes, then suddenly the fuse gets melted. And when fuse gets melted, it cuts the circuit or it breaks the circuit. So that's why the current will not pass. Okay, because of its breakdown, the current will not flow in the circuit, and all the device which are using that circuit will be safe. And here another word is given, short circuiting. Short circuiting. So short circuiting means plenty number of switches are connected to a signal. In such a situation, the current in the circuit abruptly increases. This is called short circuit. If current in the circuit is increases, then it overloading. Due to the overloading can occur when the live wire and neutral wire come into direct contact. So one reason is the live wire and neutral wire come in the direct contact. That means negative and positive wires comes in the direct contact, then what happens? The overloading happens. And in that case, the current increases abruptly, damage due to the device is damaged due to the short circuiting. Okay, that is given in page number 132. Overloading can occur when the live wire and the neutral wire come into direct contact. This occurs when the insulation of wires is damaged or there is a fault in the appliance. In such situation, the current in the circuit abruptly increases. This is called short circuiting. So, what is the reason for short circuiting? The live wire and the neutral wire come in direct contact. When the live wire and neutral wire come in direct contact, then suddenly what happens? Overloading happens. Overloading means it is increase in the electrical energy at a particular position or in a particular circuit, and because of that short circuit happens. Okay, or suddenly fire comes. So how that direct contact? Here the wires are insulated. So live wire is insulated with red color and neutral wire is insulated with black color. And here it is given that when the live wire and the neutral wire come in direct contact with each other, overloading happens. So that is because of the damage in the insulation. Okay, because of damage in the insulation, if it is present, then when the two wires comes in contact, suddenly current will increase abruptly and short circuit happens. So this is about use of fuse and overloading. Then another one law, that is Maxwell's right hand thumb rule, that is given in page number 122. Page number 122. Maxwell's. Okay, so Maxwell's right hand Maxwell's right hand thumb rule. Page number 122. Page number 122. So you are given, imagine that you are holding a current carrying straight conductor in your right hand, okay, in your right hand, such that the thumb points towards the direction of the current. Okay, for example, this is a conductor and I am holding that conductor in my right hand, and this is thumb. Then thumb, if it shows the direction of the current, for example, the thumb, it is in the upward direction, that's why I am considering the current is flowing in the upward direction. In that case, then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field as shown. This is known as the right hand thumb rule. So when we hold a current carrying straight conductor in our right hand, then if the thumb represents the direction of the electric current or direction of flow of current, then curl of the finger, curl. So here around this conductor, the fingers, the remaining four fingers are wrapped around that, and that shows the direction of the magnetic field. So according to Maxwell's right hand thumb rule, when a current carrying conductor, when you hold current carrying conductor in your right hand, and if the thumb represents direction of the electric current, then the curl of the finger shows the direction of the magnetic field. Just note on the definition, or just note on the statement of Maxwell's right hand thumb rule. When we hold a current carrying conductor in our right hand, if thumb represents represents the direction of the flow of current, direction of the flow of current, then the curl of the fingers, then the curl, that means the curl, the wrapping of the fingers, curl of the fingers shows the direction of magnetic field lines or magnetic field. So this is the statement of Maxwell's right hand thumb rule. Just note down that statement. Maxwell's right hand thumb rule. According to Maxwell's right hand thumb rule, when we hold a current carrying conductor in our right hand, if thumb represents direction of flow of current, then the curl of the finger shows the direction of the magnetic field lines. Also, in page number 1 or 2, in the lower part it is given that this rule is also called Maxwell's corkscrew rule. This rule is also called as Maxwell's corkscrew rule. If we consider ourselves driving a corkscrew in the direction of the current, in the direction of the rotation of the corkscrew is the direction of the magnetic field. Okay, they consider screw, the different composition or the rotation of the screw lines represent the magnetic field if the screw is in the direction of the electric flow. Okay, this is about Maxwell's right hand thumb rule, or it is also known as Maxwell's corkscrew rule. Thank you everyone. I'll continue in the next class.